Hello and welcome everyone to the second day of the second annual Hydrogen Aviation Summit. We're delighted you've joined us today to explore how hydrogen is set to deploy across the aviation system. You could be anywhere and you chose to join us, so thank you very much for being here. As you know, my name is Lisa Ann Pinkerton. I'm the founder and chairwoman of the international nonprofit Women in Clean Tech and Sustainability, and I'm also the founder and CEO of Technica Communications. We run the public relations and marketing efforts for ZeroAvia alongside the London-based firm Medano in Europe, and we've helped ZeroAvia organize this summit for you today. Similar to yesterday, we will be having an active Q&A. So please send your questions throughout the event to the chairs, and you can do that using the Q&A function at the bottom of your screen. Our keynote speaker for today is the head of sustainability at British Airways. She is responsible for the airline's strategy for environment, diversity, and inclusion, as well as well-being and community investment. She's also a chartered environmentalist and a fellow of IMA, which stands for the Institute of Environmental Management and Assessment, as well as a registered environmental auditor. So please welcome to the virtual stage, Carrie Harris.
Thank you very much, Lisa Ann, and thanks to ZeroAvia for organising this incredible event. So I'm just going to give a quick overview really of our new sustainability programme, Be a Better World, which we recently launched. And within that, talk about specifically our pathway towards net zero carbon emissions by 2050. And within that, the opportunity then for hydrogen and how we see that playing a part. So next slide, please, Ben. So for us, we believe that flying is magical. You know, that'll come as no surprise to you, speaking as an airline. But, you know, to put some colour on that, you know, it is an incredible achievement of humanity. It connects families and loved ones. It enables global trade, connects cultures, and opens people up to new experiences and perspectives. You know, I genuinely believe it's a force for good in delivering aid when people need it most. But we absolutely recognise that that comes at a cost. And next slide, please, Ben. So for us, you know, we have got a long track record of putting sustainability at the heart of our business. And we were the first airline group to publish our carbon footprint back in 1992. We were the first to voluntarily participate in carbon pricing and emissions trading scheme. And we were the first airline group as part of IAG to commit to net zero CO2 emissions back in 2019 when we launched Flight Path Net Zero. So now, next slide please, Ben. Now what we're doing is putting sustainability right at the heart of our core business model in British Airways. And in September, we launched our new programme around that, which we call Be a Better World. Next slide, please, Ben. I'm going to keep you busy. So Be a Better World, we're calling it our most important journey yet. And we genuinely believe that, because really finding a solution to decarbonising aviation and to making sure that for us as a business, we can build on all the good that I've already outlined that we bring to society, but making sure that we tackle the challenges that come with operating a large airline is now embedded as a core part of our business model and our future plans. Next slide, please, Ben. So we've articulated this around three main pillars of our strategy. The first one is around people, and we've set out plans here to create a great place to work where everyone can thrive. And with that, we're really focusing on enhancing our diversity, our gender and ethnic diversity, and really helping our workforce understand the opportunity of sustainability and the role that each and every one of our colleagues can play in helping us deliver our sustainability goals. The next pillar is planet, and I'll talk a bit more in a moment about our pathway to net zero, but it's also broader than that. We're also looking at a whole kind of circular economy principles and how we can embed that in our whole supply chain, and how we can also tackle waste and reduce single-use plastics, and food waste. And the final piece is around responsible business. And within that, really, it's looking at every part of our business, all our core processes and our assumptions, and how we can embed kind of sustainable thinking into the decisions that we're making. And also about how we can give back to the communities where we operate and where we serve. And we announced a new community investment fund as part of that. So today, because the focus is about hydrogen, I'm going to focus on the planet section, and in particular on our flight path to net zero. So next slide, please, Ben. So I do have a very short film that can give you an introductory overview to that. So I hope we can play that for you now. And then I'll come back to just describe then the opportunities and how we can illustrate that hydrogen has an important role to play in that pathway to net zero. So Ben, if you could play the film, please.
At British Airways, we're on our most important journey yet. For more than 20 years, we've led the aviation industry in tackling climate change, publicly reporting our environmental performance since 1992. And since 2002, we were the first airline to participate in emissions trading and set ambitious climate targets. Now, as part of our journey with BA Better World, we're stepping up our program to redouble our efforts towards a goal of net zero emissions. As an industry, aviation is currently reliant on fossil fuels. The low-carbon solutions for aviation are more complex than for many other sectors, but we believe our ambitious goal is achievable. With short-term action already in place and development and innovation underway for medium and long-term solutions, we have a clear plan to deliver it. It's our flight path to net zero. If no improvements are made to efficiency, then aviation's carbon emissions will grow over time as the demand for air travel increases. By investing in our aircraft, changing how we fly, and in time, introducing new low and zero-emission aircraft, we will deliver about a third of our emissions reductions by 2050. A further third of emission reductions will come from switching to sustainable aviation fuel, meeting about 50% of our fuel needs by 2050. The final third will come from robust carbon reductions and removals in other sectors. We're also offering our customers the opportunity to fly carbon neutral today, which means together we could reach our destination sooner. We're under no illusions. Decarbonising aviation is a big challenge, but we have a plan and we are already taking action. In the short term, we are already investing in new aircraft that are up to 40% more fuel efficient than those they replace. Deploying technology and applying management focus to improve operational efficiency. Powering our bases with 100% renewable electricity, so aircraft on stand and mototok pushback tugs are fueled by wind power. We're also offsetting the CO2 emissions of all our flights within the UK, meaning customers on domestic routes are travelling carbon neutral, and providing customers flying further afield the opportunity to offset their emissions through verified carbon reduction projects and sustainable aviation fuel. For the medium term, we're investing in first-of-a-kind sustainable aviation fuel plants to scale up the availability of this drop-in replacement for fossil fuels. We've invested with Velocis on a project in the north of England to build Europe's first commercial plant that converts household waste into jet fuel. And we've invested with LanzaJet for plants in the USA and in the future, the UK, that will supply us with sustainable aviation fuel. By 2030, we've committed as a group that 10% of our flights will be powered by sustainable aviation fuel. For the long term, we're already in action now, investing in research and innovation that will deliver solutions to truly decarbonize aviation, such as game-changing zero-emissions aircraft. Hydrogen propulsion systems could be powering short-haul aircraft from 2035. Breakthrough scale-up of carbon capture technology. And through our purchase of high-quality verified carbon reductions, we can direct vital funding into nature-based carbon removal projects that protect valuable ecosystems and biodiversity. Together, these short, medium, and long-term actions map our way for flight path net zero, our commitment to net zero CO2 emissions by 2050. But we cannot succeed alone. We'll continue to encourage industry partners to play their part. We'll need governments to create strong policies and incentives and enable our industry to decarbonise. And we'll work with our customers to help them reduce their carbon footprints as well as ours. Although we have a long journey ahead, we're not resting here. We'll keep our plan under review, seeking opportunities to act faster and deliver benefits sooner, because that's what we believe our planet deserves. Our flight path to net zero is part of our most important journey yet. BA Better World.
Thanks, Ben. So there, just to illustrate, just to reiterate really where hydrogen has a role to play, it's in both of these kind of top two wedges that you just saw on the film there. So the top wedge there relates to the emissions reductions that we can deliver through investment in new, more efficient aircraft. And that includes the types of aircraft that are coming into the fleet now, like the A320neos on the short haul, or the 787s and the A350s on the long haul, that are up to 40% more efficient than the aircraft they replace. And within that, as you heard there, from 2035 onwards, we believe we could start to see introduction of hydrogen-propelled aircraft that are viable within our fleet, and that can scale up then towards 2050. In the middle section, there's also an opportunity there for use of hydrogen in sustainable aviation fuels, to help create synthetic sustainable aviation fuels. So next slide, please, Ben. In fact, you can go forward to next one for that covered. Thanks. So yeah, as I said, for us, the key opportunity for hydrogen within aviation is there's two main channels. One is the direct propulsion through hydrogen fuel cells, or later potentially for liquid hydrogen as well, and the other is through helping with electrolysis to kind of split out the carbon to then make synthetic aviation fuels. So looking at the direct kind of use of hydrogen for hydrogen propulsions, such as ZeroAvia are doing. So we started collaborating, speaking with ZeroAvia back in around 2018. And we're just really encouraged with the pace that the technology is advancing. So when you look here, at our summary, we're just observing the progress that ZeroAvia have made from 2019. Operated the smaller kind of 6-seater size first hydrogen fuel cell powered flight. Then this year, operating a kind of 200+ mile route in the UK, and later scaling up to 19-seat aircraft on a test flight later this year. We do feel optimistic that by 2035, we hope to see single-aisle replacement aircraft that could be using hydrogen propulsion systems. And I think what's incredibly encouraging is, ZeroAvia is one important player, but actually we're seeing a kind of growing consensus amongst many operators and innovators in this space that the opportunity for hydrogen in aviation is real, and that the timescales, there is consensus around that kind of materializing later this decade, and for the kind of scale of flights that we're looking at towards the middle of 2030s. Next slide, please, Ben. So at the end of 2020, we then began to partner with ZeroAvia in our Hangar 51, which is our parent company IAG's startup accelerator program. So it's a 10-week kind of short, sharp project, and we just used that as an opportunity to really start exploring what is the art of possible for hydrogen within the IAG network. And really what it illustrated to us is actually there could be some real benefits that come from aviation, there could be lower operating costs, and we think traveling on zero emission flights could really appeal to our customers. So for us, it was so encouraging to see that if the technology continues to evolve as we hope it will, then by 2050, the majority of our short-haul routes, certainly within Europe, could be operating on hydrogen propulsion systems. So next slide, please, Ben. So we moved forward then, despite being in the middle of the pandemic early last year, so around March, April time. We actually moved forward with ZeroAvia into a co-investor with a number of other partners shown here. Even though we were in the depths of the pandemic and really the most difficult time in the history of aviation, we took that step to invest because we're absolutely certain that the future of aviation has to be about decarbonising. So for us, just as we kind of said farewell to our beloved 747 Queen of the Skies, we also kind of ushered in for us what we hope will be a new era of zero emission flight. And it's clear for us that aviation really needs multiple solutions to deliver the change that we need through the short, medium and long term. And hydrogen, we believe, delivers that really exciting opportunity for long-term decarbonisation. And that's why, our investment, we see that as a very important signal to help encourage further innovation in this space and to help attract kind of government policy and investment to accelerate the pace of change. Next slide, please, Ben. So part of the partnership with ZeroAvia was to try and look at, what are the tangible implications. And one of the findings that we looked at when working on the project was to try and bring to life, what volumes would we need to operate our short-haul fleet. And for BA, if we look forward to 2050, we identified that it could be over 200,000 tonnes of green hydrogen. And so the implications for that then are the kind of volumes of renewable electricity that would be needed to then drive that. Having said that, though, there's constant innovation in this space, and we're hearing now about other opportunities to produce green hydrogen, from heat. So maybe electricity isn't the only pathway to that, but I thought it was really valuable to us to just help kind of see the size of what would be required. Next slide, please, Ben. So just to sum up this penultimate slide, so for us, our focus really is on the prize that kind of sits in the mid-2030s. For our operations, it's really the 100+ seat aircraft that interests us. So we're just really delighted to support and encourage ZeroAvia's progress in driving the innovation in this space, and we welcome more of the same. I think it's really encouraging as well to see the government's commitments and the recognition that they've given to aviation and the need to kind of attract investment and kind of help drive further collaboration so that we can both kind of scale up the infrastructure that's needed for hydrogen, the production of hydrogen, as well as the kind of aviation propulsion systems. And I think I've kind of made the point, but I think just to reiterate that we do still believe that the role and the demand that comes from aviation needs to be properly considered in the wider hydrogen strategy within the UK and more broadly globally. What I'm kind of optimistic about is the fact that I believe that aviation has illustrated we're a really innovative industry. While some of our aircraft have long lifespans, actually we can move fast and we're constantly kind of reinventing what we do. We've adapted, we're hopefully coming out of the pandemic and looking forward to a much more rosy future. So next slide, please, Ben. And really just to sum up that for us, as I said at the start, this is only the beginning. We are genuinely excited at what's ahead. And I think, the massive challenge of decarbonisation within aviation is definitely a kind of prize worth fighting for. And I really hope that through what we're doing with BA Better World, we can help bring all our partners together to achieve that by 2050, but ideally sooner if we can. So that's it from me then. Thanks.
Thank you, Carrie. It's so inspiring to see the advancement that airlines like British Airways are making, and the plan that you have, very detailed efforts that you're putting forward here. So thank you. I have a few questions. We have some time for Q&A if you're game.
Yep.
And audience, please feel free to ask your questions in the chat below. happy to field some questions directly from you. So, Carrie, yesterday we had UK's Aviation Minister, Michael Courts, join us. And he spoke about the Jet Zero mission and the UK's aims of leading global efforts in sustainable aviation. And so I'm curious, from your perspective, what do you think we could expect over the next year, especially from COP26 onward, in this sector as a whole? What are you seeing?
So I think, yeah, as I just said, it's incredibly encouraging, the investment that we've just seen from government. And I think the focus that's gone in from government over the last couple of years, setting up the Jet Zero Council and the Fly Zero programme through the ATI, amazing kind of programmes there, and all the spin-offs and projects that kind of are happening around those. So for us, the announcement last week really helped consolidate a lot of stuff, a lot of work that has been going on over many, many years, kind of working with government, trying to kind of clarify the asks that we were setting out. So for the policy incentives, and this applies as much to hydrogen as it does for sustainable aviation fuel and carbon capture and storage. I think all three of those solutions for aviation require the same help, just to bring the first of a kind technologies to scale, and then we can run with them. So for us, we've been lobbying government first of all for kind of the right incentives. Obviously what I said there about kind of green hydrogen and renewable electricity, we've been also asking for that as part of that, and I think we saw some of that announced last week. In terms of COP, aviation's global regulator is ICAO. And so it doesn't have a huge role to play in COP, but for COP, we could see some really important progress in terms of the global carbon accounting opportunities. And if we can get resolution on that, the kind of Article 6 solution from the Paris Agreement, then it could mean that we can get, drive the investment, for example, through the UK emissions trading system, so that we can get investment into UK innovation to decarbonise. The funds that are raised in the UK, for example, could be then diverted into a green innovation fund through that. And then just towards the kind of ICAO piece, for next year is the ICAO General Assembly. And I think if we can see momentum and a successful outcome from COP, then hopefully that helps then ICAO next year at the General Assembly also commit to net zero for aviation as a whole. And that's really what we're lobbying for.
Mm-hmm. Okay, thank you. That's some good stuff for us all to do our homework with and track in the coming year. Thank you. You mentioned the customer's ability to, passengers' ability to fly net zero now through perhaps carbon offsets. Do you think that, how do you think the customers are going to respond to some of these new technologies and solutions, and are we seeing that pick up already in terms of offsetting their travel?
Yeah, so when we launched Be a Better World at the start of September, we also announced that we were purchasing sustainable aviation fuels enough to power all our flights between London and Glasgow and Edinburgh during the COP conference. And we also announced that we were offering, alongside the carbon offsetting that we've run for several years now, also offering for the first time the opportunity for customers to purchase sustainable aviation fuel alongside their offsets. That offer, it's about 5 times more expensive than the carbon offset, the traditional carbon offset. But we've been so encouraged, we've actually doubled the amount of customers that are purchasing offsets overall. And of all the customers that are offsetting, 25% are selecting the option with SAF. They really want to help decarbonise in the sector. And so I think that I just find that incredibly encouraging. Overall, at the moment, the number of kind of customers that are offsetting is quite low, but we're just working on different solutions to help make it more accessible and easier, and to help people can feel informed and understand, how that's actually driving carbon reductions.
Mm-hmm. Oh, that's encouraging to hear. We have time for one question from the audience before we move on to our first panel. And the question is, from 2027 on, Airlines would be included in the ETS trading system. UK and CH also stay within ETS. So how and when do you expect that this will affect British Airways and airlines in general?
We've been part of the ETS since 2010 when we joined the UK ETS voluntarily, and since 2012 in the EU ETS. Now we're back in the UK, the new UK ETS, so we're already part of that. We're very used and we kind of really encourage that cap and trade mechanism. So, over time, and maybe the question was getting towards the fact that the free allowances that come within that will be phased out. So it just means that, there's a bigger obligation on us. But, we've long lobbied for effective carbon pricing for aviation, and emissions trading systems, cap and trade is the best policy for that it's the most robust carbon pricing mechanism because it's fair and it helps drive, reductions across the economy in the place where it's most cost effective. So we absolutely support that. And we're also in parallel, that works for the domestic market and for Europe, in parallel working on the global mechanism, which is CORSIA, which is a first of a kind, sectoral carbon pricing scheme for aviation. And we're also supporting that through ICAO and through lobbying with IASA then for that long-term vision to get to net zero globally.
All right, thank you very much. Thank you very much, Carrie Harris, for joining us today, Head of Sustainability at British Airways, and thank you for all the hard work that you're doing to make aviation more sustainable.
Thank you very much.
All right, you're
welcome.
welcome. Thank you for your time. We have, for those of you who did not attend yesterday, I want to invite to the stage the man who is the catalyst for bringing us all together. He's going to give us a wrap up of day one. He's a serial entrepreneur with an appetite for tackling complex and challenging technology problems. Most recently, he pondered, what's the most practical and scalable way to make airplanes zero emission? And so now we have ZeroAvia. So when he's not inspiring us to use our individual talents to make the world a better place, you'll find him using his helicopter and pilot licenses. Please welcome back to the summit, the founder and CEO of ZeroAvia, Val Miftakhov. Val, the floor is yours.
Thank you, Lucien. Hey, everybody, again, hopefully we have a lot of people from last day, but for the new participants, I thought it would be great to give a little bit of a recap of the last day. We had a great day yesterday of a great keynote speaker. Aviation Minister Robert Kurtz gave us an overall view of how the UK thinks about the decarbonization of aviation, and not just for the UK alone, but for the entire international market. And of course, United Kingdom is looking to lead a lot of this transformation and has been quite instrumental already in doing so. So this is a great session, lots of questions, and I think it was the result of this was a reinforcement of that understanding that the UK really understands the importance of cleaning aviation, really understands the types of technologies that will be needed for it, and is committed to continue pushing on it. Then we had two great panels. The first panel on the power plant side, and we had a number of executives from a variety of different types of companies. We had Glenn from Airbus, the VP Zero Emission at Airbus, providing the OEM perspective. It was great to see the view that, of course, Airbus thinks that hydrogen will be a major force in clean aviation, but also some detailization of the concepts around the hydrogen fuel production, fuel infrastructure at the airports, liquefaction, and other components of fuel infrastructure. It was great to see some of the vision for distributed production and fueling. Also, it was good to see some further details on the concepts of aircraft that Airbus is looking to bring to the market. Then we had Carl from PowerCell, and of course, there's a fuel cell company that is probably the largest fuel cell system that has flown in an aircraft, and of course, ZeroAvia aircraft. And this feat will be again repeated pretty soon with the larger aircraft, the 19-seat aircraft that ZeroAvia is looking to fly. So Carl talked to us about the key issues of adapting the fuel cells to aviation use case, including the power density, specific power metrics, and the durability. How many hours we're going to get from these systems? Good references to the heavy-duty cases on the ground, where in heavy-duty trucks we see 20,000 hour plus endurances of these fuel cell systems, which are dramatically higher times between overhauls than typical small and medium-size turboprop engines. So this is very encouraging. Then we had Chris from ATI, Aerospace Technology Institute, that is operating the world's, what do we think, the world's most concentrated, most advanced aerospace R&D or aviation R&D organization with about £4 billion of the total budget. And of course, ATI has supported a lot of work by the innovators in the hydrogen flight ecosystem, including ZeroAvia, but also some other projects that are quite well positioned in the UK. And of course, Chris is the director of the Fly Zero program, which is looking over the last number of months, was looking at the top level first principles view of what clean aviation should look like. So we had Chris share some of the thoughts on that, and the quick summary of that. I'm sure there are a lot of different details that I'm missing, but liquid hydrogen is a critical fuel for the future of aviation. And then we had Pasha from Alaska Airlines. And of course, we were proud and honored to announce yesterday that we're partnering with Alaska Airlines to be the first passenger airline to fly hydrogen aircraft of large turboprop size. And we're partnering with Alaska to bring that to fruition here in the West Coast. So Pasha shared a lot of interesting details on how the operators look at hydrogen flights and clean aviation, how this would bring new opportunities to the operators, so not just make the existing business zero emission and clean, but also open up new opportunities for connectivity, new routes, new potential destinations where perhaps before excessive emissions, excessive noise, and other factors could have prevented operations. So it was good to hear that as well. And then we had a second panel, which was talking about the specific technology developments. And we had great members there. Alex from High Point working on revolutionary high temperature fuel cell technology that has a potential to dramatically increase the performance parameters of the fuel cells and therefore make it even more attractive for aviation use and deliver longer flight times and higher payloads, which is what all the operators want, cargo and passenger. We had Craig, CEO of Hyzon, which is another major fuel cell company with heavy-duty applications, most notably in the heavy-duty trucks. And Hyzon fuel cells of new generation have made the news over the last year or so with some third-party testing with National Renewable Energy Labs here in the US. showing them as the most energy dense, most power dense, and high specific power fuel cell cores that exist. So we're happy to have Craig there as well. Hexagon, Matthew talked about the fuel storage challenges, and it was great to hear that we are getting in a pretty good shape on the gaseous storage with various technologies, getting to the performance levels that enable true commercial flights in the sub-regional segments. The 10 to 20 seat aircraft, of which there are thousands and thousands in commercial use worldwide. So this is really great to hear from this leading company that builds some of the greatest hydrogen tanks out there. And then last but not least, we had Margaret from Mitsubishi Heavy Industries Regional Jets division. And of course, we are very happy and honored to having announced earlier this week on Monday our partnership with MHIRJ on a variety of topics, including adaptation of our larger engines to the CRJ family regional jets, which are, of course, as Marge mentioned, are some of the largest segments of regional jets with over 1,000 jets operating by various operators. So this is a really exciting time for regional aviation. And Margaret had a few things to say about how exciting this future of hydrogen is for regional aviation, for MHIRJ specifically, and how we all look at all these regional operators that are flying these jets to go and transition to the new zero emission future over hopefully a relatively short period of time. We do expect these types of vehicles to be available commercially within this decade, working on hydrogen. So really great set of panels yesterday. We'll of course be making the materials, the presentations available on our video stream later after the event. But hopefully this gave you a good summary of what we had yesterday. And today we're going to have two other very interesting panels. We're going to talk about specific applications and deployments of this technology, hydrogen aviation, propulsion, fuel storage, fuel delivery, production. So the first panel will be about hydrogen refueling, fuel production and refueling. We're going to have some great participants, and I'll let Grahm to introduce them more deeply, but you will hear from the experts on hydrogen fuel in that panel. And then we have another panel later in the day on hydrogen zero emission applications as well, which will have participation from the operators, from the overall research agencies that will talk about specific items that will be critical for actual deployment on the ground with the actual operators. So hopefully, last day was about the power plants and technology that goes into it, and this day is about taking all that technology, putting it into action, and this is how we're going to see all this wonderful technology, wonderful approaches actually delivering zero emission travel. So thank you for joining, and looking forward to great discussions.
Thank you very much, Val. Those clip notes are very helpful, and I think we will be able to use that content in other ways. So thank you very much. We have our first panel to get started here. We're looking at the future of hydrogen refueling infrastructure. And I'd like to welcome to the virtual stage our chair of this panel and managing editor of Technolgy at Aviation Week since 2008, Grahm Warwick. Grahm, the floor is yours.
Hi there. So you froze there for a minute. Hi there. Grahm Warwick here of Aviation Week. So We all know that aviation is a system. It's a system that has been developed over decades, and there are many things that we take for granted about that system that enable it to be safe, reliable, and efficient. And one of them is how we get fuel from where it's produced and into the aircraft where it is consumed. And when you start talking about hydrogen, you start talking about changing the way that it's produced, the way that it's distributed, the way that it's stored, the way that it's refueled, and the way that it will be kept safe through all of that process. So we have got to ask and answer some questions about how the fuel production industry, the distribution industry, and the airport operators can not only bring hydrogen to the airport and get it into one aeroplane, but actually then scale so that we can do this on the level that we currently do with fossil fuel, with kerosene, in the billions and billions of gallons and millions of gallons a day. So we have some big questions to ask and answer. And with us today, we have a great panel that represents that sort of fuel supply to airport operator supply chain and can talk about this. So with us, we will have Paul Bogers. Paul is Vice President for Hydrogen at Shell. Paul was recently appointed to this role where he is looking after all aspects of Shell's growing hydrogen business. That's actually one of the things that we're seeing. The traditional fuel suppliers are becoming major players in the hydrogen economy. And they know a lot about producing and moving fuel around the world. So he's working on both hydrogen for transportation and for industrial uses. Before that, he was Shell's VP for fuel technologies, so he has a good background. Also joining us is Ahmad Bakkar. He is head of strategy and innovation for Rotterdam, the Hague Airport. Ahmad is responsible for innovation projects, including urban air mobility, another one of my favorite areas, and electrification, and in building out collaborations with technology innovators. In one of those nice convergences, he's also an aerospace engineer by collaboration and a former Shell employee. So, and then finally joining us is Ben Eaton. Ben is engineering director and co-founder of OCTOPUS Hydrogen, which is a new name to the industry, a UK-based supplier of green hydrogen for heavy goods transportation, which is where a lot of what aviation is going to draw on is getting started. Industrial applications, obviously, and now aviation, not only in the UK, but in Europe and Australia. Ben is a chartered mechanical engineer and a commercial pilot. And he was at Cavendish Nuclear, and we all know that someday nuclear may come back into the frame as a way to actually generate this hydrogen. So you may find it with two hats on some point in your career. So we're going to start with Paul, then go to Ahmad, then go to Ben. Please put your questions into the Q&A, and we'll take those after we've had the initial presentations from everybody. So Paul, take it away.
Yes, and thanks so much for that intro, Graham. And it was really interesting to listen in on Val giving a summary of all of the panels and the discussions that have already taken place. So really excited to be here. As Graham mentioned, I look after hydrogen for Shell as a whole. The reason I'm wearing PPE is that I'm actually at a place we used to call a refinery, and we now call it an energy and chemicals park in Rhineland. And today was the first day we produced hydrogen from our 10 megawatt kind of PEM electrolyzer here. So it was a big day for everyone involved in that in that project. If I reflect on what is needed to kind of provide the infrastructure and the backdrop and the energy, the zero carbon energy for the aviation sector, it's quite daunting. So in one of my previous roles, I was the head of aviation technology, and near my desk was a small typed letter signed by Sir Frank Whittle. And on that letter, he thanked Shell for donating the illuminating kerosene that he used for developing the Whittle Unit 1. And probably that was the last time that this kind of transformational change happened, to move from high octane aviation gasoline to the kerosene that we've all know and love today. So I think we're not blind for all of the challenges that would be required to move to hydrogen. A lot of my day job is involved in understanding how we can bring what we call the levelized cost of hydrogen down. How do we produce green hydrogen or clean hydrogen at the lowest possible cost? A lot of that has to do with scale up and looking at industrial customers that require the scale of hydrogen that can really bring the cost down. And then at the same time, thinking about how mobility use cases, whether that's light duty mobility, whether that's trucks coming onto the road, but also sectors like marine and aviation coming into play much sooner than we originally thought they would. And I think we then had a choice point around learning about these different sectors. So we know about light duty refueling. We've got a network of close to 100 sites across Germany refueling light duty vehicles. But it'll be no surprise that the demand simply isn't there. So whether you call it the chicken or the egg, one of them didn't show up in that context. Very different picture around the demand side in California, where we've learned a tremendous amount how to do it better, how to also make sure that the vehicles are in the market. And the hydrogen refueling stations that we're building there today are double the capacity and half the cost than where we were about 3 years ago. So there's still a lot of innovation that is happening around the cost. Now, I talked about cost a lot, but of course, safety is paramount. And that's true whichever kind of sector you apply it to. But aviation is probably the most safety conscious sector, where you have to be in your 10 to the -9 in terms of failure rates and all of the other contexts. So aviation wouldn't be the point where you would start. If you flip the argument on its head, though, the number of sites where you would have to build infrastructure, the airports that really matter, including some of the regional ones, are probably only counted in the hundreds instead of the tens of thousands of refueling sites you need to cover road transport. So it is actually a sector where you can make a difference with a limited number of point-to-point combinations and creating corridors for starting off with hydrogen. We had a choice when we started to kind of explore what opportunities there were for hydrogen in aviation. We could pay quite a lot of money to big consultancies to write thick reports about when hydrogen was ever going to happen, or we could make a small investment in a company like ZeroAvia and learn with Val and Sergey and the team to see how they look at the world and how they see hydrogen playing a role in aviation. And we've learned quite a lot already. We're on that journey together, and we're really excited to see where that might take us. My personal perspective is that I'm less worried about seeing some of the numbers that Carrie from BA showed around, well, how much hydrogen should be produced compared to the broader energy system. If we move to a hydrogen economy, that's not my worry. It's about how do you bring it safely and cost effectively to all these airports, because that last little stretch between the point of production and where you have to put it on board of a plane, especially if it's a cryogenic fuel, that's probably where most of the innovation still needs to happen. But let me pause there because we do want to hear from the other speakers and I think have a lively panel discussion.
Thank you, Paul, and I think you've pointed out there that what I'm seeing not only in hydrogen but in electric and other areas is that the technology sort of is there, and it's maybe in some other sector. Aviation, aerospace engineering gets stuck into that technology, and we do see a rapid advance from that original technology to what is now available. Now we have the hard stuff to tackle, but the technology has moved incredibly fast as we've applied our understanding to these technologies to produce specific applications. It's incredible how quickly that has happened. So I'm going to go now to Ahmad, who's at the other end. He's at the receiving end of all of this. So Ahmad, talk about it from the airport operator's viewpoint.
Thank you very much, Graham. And I think I'm not the only one with an aerospace engineering training on this panel. as Paul had that as well.
I think we all have.
So, so what I'm going to do is just tell you a bit about how we at the Royal Schiphol Group, but also at Rotterdam The Hague Airport, look at this disruptive technology, at this revolutionary technology in the aviation industry, and what we do to go along with it. And then eventually how we value cooperation with pioneers in the hydrogen, but also other pioneers that actually work on clean aviation technologies. So Royal Schiphol Group is basically looks after different airports. One of them is Rotterdam The Hague Airport, and Rotterdam The Hague Airport is basically an innovation platform where we try to bring in new technologies of the future. We try to put them out there, experiment with them in order to be able to innovate. Electric flight, hydrogen technology, sustainable aviation fuel all together. But why do we think that hydrogen is one of the most important one, or the important ones as well? It's because we are located in a very specific location, close to the port of Rotterdam, close eventually to Shell, and we have connections. And as you might have heard, we have established a partnership today together with ZeroAvia to basically start the first commercial flight out of Rotterdam to London. And so all these things from an airport perspective would mean, going back to the start, how can we make sure that we have the right infrastructure? How can we make sure that we have the right supply chain and the fuel coming into our infrastructure in an EASA approved way in order to operate it? And we do that not only by experimenting and innovating, but also by walking along with the partners, the developers in this certification process, by learning together and by basically going in this learning process and feeding back. So this is a bit the background. And if I want to take one very important point of what Paul has mentioned before, it's safety in the aviation business. We always used to learn that the safety factor is 1.5 at least for the aviation, while for other sectors it's 1.1, 1.2. And what's more important than that is that we have to have a fail-safe every now and then in certain critical systems. So having said that, the difficulty is there, but we need to be ambitious. If we don't work on innovative way to make this happen, we will not be able basically to make this breakthrough that we are actually asked by the stakeholders around us, by the travelers around us to do. And we are not able to do that by ourselves as an airport, as a regional airport. We are able to do it together as an industry, from the north to the south, east to the west. So that's a bit how I look at this.
Thank you, Ahmad. You make a very good point there. I like the idea of having an airport that's dedicated to innovation and experiment. It seems to me that hydrogen is one of those technologies that you can begin in one place and sort of experiment and do something useful, because you can fly out and back or whatever, or something like, if you do electric, you're going to probably have to have a connection at both ends or something. And some other technologies, when you look at airspace technologies, you need it at both ends, so there is an ability for one airport that has an experimental mindset to really make a difference, I think. So let's move over now to Ben at OCTOPUS. Hi, Ben.
Thanks a lot, Graham. Thanks for the introduction. Thanks for the heads up on the nuclear. You've usurped me already, but yeah, it's great to be here. So thanks to ZeroAvia for giving us the opportunity to talk about what it is OCTOPUS Hydrogen is doing. Given, as you referenced, Graham, it is quite a new company, so perhaps most people won't be familiar with what we're doing. I'll probably take this next few minutes just to talk through where we're up to, what and how we came to be, in effect. So Those of you in the UK are probably familiar with Octopus Energy. So Octopus Hydrogen is part of the Octopus Energy group. But Octopus Hydrogen exists specifically for two principal reasons. One is the decarbonisation of the electricity grid, and the other is to decarbonise hard-to-abate sectors, transport sectors. So obviously we're talking about buses, trucks, aircraft, and then later down the line, marine and rail. So we do that in two particular ways. One is by co-locating physical assets. So we're looking at co-locating electrolysis with wind and solar in the UK. So that's where we'll be looking to produce the cheapest possible kilos of hydrogen. And I think Val particularly be very aware of the benefit of having an on-site demand and what that offers to a grid balancing mechanism. So that's hugely important to us, because ultimately what that allows us to do is continue to offer viable commercially viable projects to renewable developers in the UK. So whether that be wind, solar, or one of my personal, well, if anyone's listening from a geothermal perspective, we'd love to get into a geothermal project as well, because I see there's huge gains in that respect. So yeah, on-site demand, co-located electrolysis is what we do, where we'll produce the gas, compress it, and then via road transport deliver it to depots or airports. And the second part of that is that we have effectively an IoT, Internet of Things software platform, which is designed to optimize the production of the gas. And the way it does that is by looking ahead in terms of so forecasting the demand, which is a big part of it, forecasting the cost of energy, understanding what the weather patterns might be, because obviously they have a huge impact on the renewables utilization. And that platform also enables us to give us a greenness audit, which we think is an important perspective from a subsidy element. So that's an important part of our business also. So those two elements, the co-location of electrolysis and also the IoT platform, is particularly important to Octopus Energy and Octopus Hydrogen. So as it stands now, we've got two projects at the 1 megawatt scale. So we've got two different electrolyzers looking to be deployed in the early stages of 2022. And hopefully you'll have seen in the press that one of those is to support ZeroAvia in their development program at Cotswold Airport. So that's that's an important project for us, and hopefully will align with the requirements as ZeroAvia step up in terms of their demand for hydrogen to support their certification program. We'll be able to match that with the electrolyzer, the storage and compression that we've got that will be located on the Cotswold Airport. So, and the other project that we're looking at is for a vehicle testing site in the Midlands, which will be announced probably towards the end of the month. So, yeah, hopefully that gives you guys some context to ask questions about how we see the provision of gas going forward, particularly in the aviation sector.
Thank you, Ben. We'll add geothermal to your many interests. Okay, so here's the question I think I want to start with. How do we get the hydrogen to the airport? So, I mean, my understanding is that you can generate it, at the production site, and then you can either pipe it as a gas or you can transport it as a liquid, but you can also generate it at the airport locally, as Ben talks about, and then either compress it or liquefy it. Do we have any sense as to what the likely approaches are, what the pluses and minuses are? Can airports really have the capacity to build large solar farms? What's the power consumption like for an airport if it has to compress or liquefy locally? Could we talk around that? How do we get the hydrogen to the airport bit? Paul, do you want to start? You're the big fuel producer. How do you want to get this stuff around the world?
Yeah, and I think the short answer is with great difficulty. So I love everything about hydrogen, except that it's a small molecule. So either you have to compress it or you have to liquefy it, and that's one of the reasons why most of the hydrogen today is produced right at the point of consumption, when it's used as a feedstock in a fertilizer plant or in a petrochemical facility. You make the hydrogen within the refinery fence. So transporting it either as compressed, kind of has limitations. So I think some of the earlier plays may well fall into that category that Ben was talking about, where you say, look, you've got sufficient capacity to make and store, a couple of tons of hydrogen on the site, and that's sufficient to fuel the few flights that there are today. Then we found certainly that hydrogen pipelines are a very convenient way of getting larger volumes of hydrogen kind of around the system. And if you look at some of the plans in, let's say, continental Europe, of aligning hydrogen pipelines and repurposing existing gas pipelines almost alongside the same major highways is an elegant way of getting a lot of hydrogen to, let's say, truck stops. So pipelines are a good way of if you have centralized production, to get it in large quantities to a site. But longer term, you might even think about liquid hydrogen, not just kind of as a midstream solution, kind of between a large production site and another kind of road transport site, because you can transport liquid hydrogen over long distances. But this is even thought in terms of the, let's say, 500,000 ton per day scale, to do it between continents. And it sounds really far-fetched, but we've got one demonstration project that is doing exactly that, transporting liquid hydrogen between Australia and Japan to prove out the different bits of technology that you would require. Now, in a world where you have liquid hydrogen being shipped over such distances, then getting that same liquid hydrogen to airports also becomes in a feasibility. Now, we're talking turn of the decade rather than something that's going to happen in the next 4 or 5 years. So you might start local, then you might have pipelines, and longer term you probably have large scale liquid hydrogen in the system.
Now that's actually transporting it as liquid hydrogen, not as ammonia to be changed into hydrogen or something.
No, that's as liquid hydrogen. I think there is, there's a whole, if you scan the internet, there's a whole list of projects with using ammonia as a carrier, or some people have called it a nitrogen wrapper. I think if you think about the challenges of converting the hydrogen into nitrogen, and then converting it back into hydrogen, the round trip efficiency, the energy losses you have across that system are quite substantial. You then have to clean it up as well if you wanted to use it in a fuel cell, perhaps less so if you burn it into a gas turbine. But I think we're studying all these different routes. We've got feasibility studies and we've got demonstrations pretty much of every flavor of hydrogen intermediate. So far, we've seen that it's much harder to do, but the most elegant solution would still be liquefaction if you want to use that hydrogen in a fuel cell at the other end of the application.
So Ben, you've got the on-site, the co-location on-site sort of approach. How scalable is that?
To an extent. So to give you an impression of the sort of scale we're talking about and what we can do now, stroke next year, we can move 1,100 kilos of compressed gas, compressed hydrogen, 380 bar in a road-going ADR compliant vehicle, which is arguably approximately 1 ton. Is probably enough to sort of. I did a couple of calculations earlier on today and sort of estimated that I think a de Havilland Dash 8, looking at 1,100 nautical miles as a range, the equivalent gas requirement would be about 1 ton. So that's just to give you some rough numbers, to give you a scale of what we're talking about, and that's where we are now. But I agree with Paul that obviously we're looking to go down the liquid route. But what I would say is the reason why we co-locate, again, just to go back to my introduction, was the fact that we've got an on-site demand for the electricity avoids some of the curtailment issues that we might have going into the future for solar and wind, which enables us to effectively get a cheaper price on the megawatt hours of electricity that we buy, which is obviously the vast proportion of the cost in the hydrogen comes from that electricity. So the cheaper you can get it, the more effectively you could hopefully scale up into the market, because it becomes more cost effective. obviously you suffer when it comes to the distribution of the gas. So what I understand is that, well, the numbers we work on is that currently you're looking at an additional 10 kilowatt hours per kilo in order to get to a liquefaction. So that equates to something like 71 kilowatt hours per kilo when it comes to producing the gas and getting that to a liquefied state. So I do think we're in a position where we, in order to scale, we are looking at liquid to transport, but I'm also thinking that there are limitations that come with the amount of solar and the amount of wind, and hopefully the amount of geothermal that we'll need. And maybe we've got here a bit sooner than I was anticipating, but we're probably looking at maybe in the longer term to scale to the stage we need. We are looking at small modular reactors, possibly into the 2050s to do this reliably. The other thing that occurred to me today, actually, and I haven't sort of sanity checked it other than to say it's probably possible to start looking at more tankering. So rather than bring the gas to the aircraft, you could almost bring the aircraft to the gas. So we might be thinking that maybe, I'm just looking at a map now, Northern Africa might be a good place where we produce hydrogen and or the Middle East. So we'd aircraft tanker now, don't they? So they perhaps fly to the Middle East and they'll take more fuel back than they necessarily need because it makes economical sense. I haven't done the numbers, but that was just one of the proposals that occurred to me today. It's not too far. It's not too much of a stretch, in my opinion.
This is so interesting because this is a return to the early days of aviation. When I started flying internationally for my job, going to the Singapore Air Show in 1981 or something like that, British Airways 747 had to stop in Qatar to refuel. And there was an airport, big airport in the middle of nowhere that was simply there because the aircraft had to refuel to get to where they were going. I mean, we're almost going back to where we'll have these massive airports in the middle of nowhere that are just there to refuel the airplane. It's tremendously romantic, actually. But can I just, sorry, Ahmad, I want to come to you next, but I do want to go, Ben, we're all struggling to understand new terminology in aviation, right? So I'm trying to understand batteries and kilovolts and watt amps per hour and all that sort of stuff. You talked about curtailment. Is that where you're getting low cost power or something? Could you just very briefly explain that to me?
Yeah, I just assumed everybody was aware of that. So ultimately, there's going to be points in time, particularly on a typically, for example, a spring day where we've got sunshine and we've got wind and we've got a relatively warm climate and there's not a huge amount of demand for power. So at that point, it's not possible to put the electricity into the grid. So they need to do something with it. So rather than just turn off the connection, having an on-site supplier or on-site demand, is a huge economical benefit to those developers because they know that if the power's not going to the grid, and then it's curtailed, hence the word curtailment, we can then use it as opposed to it just being used, well, it goes nowhere and adds no value. So that's partly why the co-location particularly in this decade, we believe is favourable from a green hydrogen production perspective.
And also, you can feed back into the grid when you've got excess power. You feed back into the grid, do you?
If we were to use the hydrogen to convert it back to electricity via fuel cells, but that's not something we're looking at. We think the value of the gas is far outweighs the value of it turning it back into back into the grid. But one thing it is worth adding there is well, I suppose just underlining the fact that making more projects commercially viable on the grid means that it sort of reaches our goal of decarbonisation across the board, because it just means that there's more likelihood of more and more developers finding the cash and finding sites to develop more and more renewable sites, which is really important to Octopus.
So Ahmad, so where does that put the airport? I mean, how do you want to get the hydrogen? Do you want to have the liquefaction on the airport, or the energy generation, the reusable energy on the airport? Do you want to play a bigger part in being part of the power brokering, that the airport is much more integrated into the whole energy picture? I don't know, just tell us how you see it from an airport viewpoint.
Well, to be very honest with you, what I want is to supply my partners and my customers with the safest way of going from A to B. That's what I want. Now, reflecting on what have been said by the panel, clearly we are in a very early stage of transporting hydrogen, of understanding how we can do it safely, and even how to use it in an aircraft as well. But understanding that and looking in depth into what the situation is at the moment, we have key enablers that we can build on based on also what Ben has mentioned, and that's basically building on local territory and building on, for instance, we're going to have soon our solar park outside the airport, and it's going to be along this, the runway. So we can use this energy in order to make hydrogen on site, and then use it for the aircraft that is going to fly on hydrogen. Now, assuming that we are in an early stage of hydrogen adoption, assuming that we are one of the airports that will do that, and that our destination airport in London, as we wish, is going to have sufficient hydrogen, that's going to be successful, I hope. Now, having understood and having looked into the energy production when it comes to sustainable energy, and especially renewable energy such as solar energy and wind energy, depending on the situation, depending on the time, depending on the how the power grid is doing, that puts us in some uncertainties as well. And uncertainty is, are we going to have hydrogen? Are we going to have enough hydrogen to schedule our flights or not? Are we going to have to build a buffer and optimize around it? How are we going to deal with it? So either way, whether it's presented and manufactured on-site or off-site, we have uncertainties that we need to explore, that we need to go around and understand. And once we understand these uncertainties better together with the partners in the chain, we can actually prepare for a better planning of how the operation will look like.
I could probably add a bit more context, actually, Graham, thinking about it. So, as I mentioned previously, that this -8, this imaginary -8 that requires about a ton in order to do the 1100 nautical miles I discussed. The amount of electrolysis required to provide that with effectively a ton a day is approximately 5 megawatts when you talk about combining it with wind and solar. So let's say we weren't co-located, and let's say we were having the electrolysis located at the airfield. We would then effectively require 5 megawatts per aircraft of electrolysis, which is significant. And you think about what the grid infrastructure would need to look like in order to do that, or very, very quickly it becomes a headache. I mean, we've had a little bit of experience in trying to get a grid connection just for the 1 megawatt site, which has proved to be very difficult. And that just might happen to be the location where we are in the world with that. But it's not trivial to get that amount of power to an airfield to do that amount of electrolysis. You've got to add to that the water requirement. So in the scenario that I keep going back to, you're looking at 15 litres of water per kilogram at an estimate in order to do the electrolysis. So at this scale, we're kind of talking that we're probably going to need rainwater harvesting, desalination plants. It's a significant amount of water required to be able to do this. So again, the whole thing is not trivial, and it's not a simple case of just deciding to develop this local to an airfield. There are a huge number of factors that mean it's a significant challenge.
So, Paul, you made the point that when you set out on the hydrogen journey, you did not expect aviation to become forward so quickly to be a customer. When we come to safety, there's a lot of questions around safety. We're literally putting the application with the highest safety standards up front in developing a lot of these things. The distribution, the balancing, the buffering, all the things we've talked about, and the safety all come rushing to the fore when you talk about aviation. can you just talk about safety, what your understanding is? Where do we stand in terms of distribution safety, tank safety, handling safety, refueling safety, where we stand today and where we have to, so therefore, how much work do we still have to do? Ahmad, do you want to talk about, from an airport viewpoint, where you think we stand at the moment on safety?
Yeah, and it's a very important point, right? And I often get asked,
Paul,
what's
and
the...
then Ahmad. Yeah, Paul, go ahead, yeah.
I often get asked, what's the one thing that could hold back, the hydrogen kind of economy coming to life, or hydrogen taking a bigger share of the energy system, and it's probably safety. And anyone who's working in this space is very conscious of that. But a tremendous amount of work has already been done around the design of crash-worthy kind of carbon fiber reinforced tanks, right, in passenger cars. The amount of crash tests that the likes of Hyundai and Toyota have put into that. And then, I run a network of over 100 retail sites, right, where you expose the general public. These are not trained professionals. These are not the same people that are hooking up your hoses from the hydrogen system at an airport. And every week there is a customer that forgets to disconnect the hose and drives away. Believe it or not, this happens all the time. So the design of the dispensers is such that there's a quick disconnect, a breakaway coupling, and all that happens is that the customer panics, rings up a technician, we go out to the site, decouple it from the car, connect it, do a functional check, and that dispenser is back up and running. So if you design it to be fail-safe, then even hydrogen refueling for the general public has been demonstrated and has been done safely for more than a decade. So I think there are a lot of design features. There's been a lot of great work around standardization and norms, but we can never take, kind of a relaxed attitude to that safety just because it's so important. I would say hydrogen safety for gaseous hydrogen at 350 and 700 bar is very well developed. A lot of the automotive folks have done the heavy lifting. Probably around cryogenic fuel handling, there's still quite a long way to go, just to make sure that the standards there are developed. And I think this is one of those areas where it's so important as an industry that we don't compete on safety, that we don't compete on having different refueling standards or different kind of couplings, because that's where the risk kind of seeps in. But again, the aviation sector is probably the best in class when it comes to standardizing refueling kind of protocols, and the fuel husbandry kind of piece is really well developed. So I think if you can safely refuel a passenger car, with the general public doing that, then doing it within the context of aviation is also feasible.
Ahmad, you've got a complex operation on airport of bringing wherever the hydrogen come from, you've got to bring it in, store it for some period of time, get it out to the airplane, presumably get it off the airplane if it comes back and needs to be defueled. What's your view on that when you look at your task of safety from handling hydrogen?
Well, so I definitely believe and trust what Paul has just mentioned. Let's start with that. But I'm going to give you my experience, like an operational experience. The first time I spoke to our fire brigade commander about hydrogen, he was extremely shocked. And luckily, he is basically active in our province in firefighting hydrogen and building capability for that. And he was a bit thrown off his game, and he's like, but we cannot feel hydrogen. You cannot see hydrogen. You cannot even smell hydrogen. If the flames, if there are flames, you cannot even see the flames. And you don't deal with it as you deal with other type of, like, let's say, kerosene. And so that's how the conversation started. And then we got experts from different safety institutes to discuss and talk about it. But the complexity, what I'm trying to say, we did not find the solution yet. Let me be very, very clear about this. But the complexity about it is that we have to take the stakeholders involved in the process early in discussion in order to make sure that we covered all the blind spots in order to make sure that we have covered all the risks. And if we can do that together, then we can at least make sure that we have all the bases covered and ready to let's say cover any risk. And one of the really nice models in the safety is the Swiss cheese model. And you'd want to make sure that you don't get your cheese crossed from the start to the end. So that's a bit how we see it. But having said that and understanding the risk, we also see the need to test, and we start small. We make sure that we are contained in an environment. We make sure that we can do it, and then we grow together. And that's how we do it also with partners along this idea of starting small and then growing around it.
Are you concerned about the turnaround time implications, or do you think that there will be solutions to do this safely in the time and turnaround time that your customers expect?
The turnaround time is a very important aspect. It's not the most important one. It can have basically. I'm giving you my personal opinion about it. It can have a commercial influence for the turnover of the airlines, etc. It can have a commercial influence on our turnover as well as an airport, on how many aircrafts we can handle. But in my humble opinion, it's not the most important thing if we take into account the fact that we want to operate a sustainable operation, a clean operation. So we have to pay the cost for that.
Yeah, and I think maybe if I can add, I think in terms of refueling kind of large kind of let's say refueling trucks, right, and getting the right flow rate compressors to refuel a truck with 80 kilograms of fuel, I think is a problem which we kind of have now pretty much cracked. So you can do that within the same time that it would take you to refuel a diesel truck. 5 or 6 minutes, you're done. The particular challenge of physics around dealing with liquid hydrogen. If you've ever been to, Kennedy Space Center, you could see you got these big kind of gravity-fed kind of towers with liquid oxygen and liquid hydrogen. That's not because they, they thought that was an elegant way of doing it, but you just can't really pump that volume of cryogenic liquids safely before you create cavitation and things like that in the pump. So and it's it takes a couple of days to fill. At the time, it was the space shuttle. So that kind of refueling time for a large passenger aircraft just wouldn't be acceptable. So I think better kind of pumps for a liquid hydrogen, I think, is still needs a lot of engineering brain power before we can do that safely and at the same speed, at the same kind of turnaround times.
So we're coming to the end here, but we have lots and lots of questions. I apologize for not getting to them all. There's one question. There's one sort of question. It's a comment here. It says that Grahm Warwick is clearly unaware of the existing liquid hydrogen infrastructure. I think that actually illustrates the problem that we face. If we only talk to ourselves within this industry, we don't get people to understand. This industry, we're seeing it with electric. We have to talk to the broader aviation industry and then to the public, the traveling public, to get them to understand. Because the technology we're talking about, and I'm pontificating here, is just so new to people. And we can easily talk within ourselves, or you guys can talk within yourselves and other people can, but we've got to get out of our boxes to explain this to all the stakeholders. As Ahmad said, we've got to get partnerships, we've got to get stakeholders, we've got to find a way to talk beyond our little circles that we talk in so that everybody understands. I mean, for me, it's fascinating, talking about curtailment, talking about how much water we need to use to do this. It's all fascinating stuff, but we're all learning. And so any opportunity you guys get to talk to as broad an audience as possible, I really encourage it. And I thank you for putting up with me today, and I will hand you back to our organizers. So Ben, Paul, Ahmad, thank you very much.
Thank you.
Thank you.
Thank you, gentlemen. Thank you, Graham. That was very informative and a lot to cover, a lot of ground and technologies to integrate here. But I really appreciate that everyone on that panel is putting a lot of thought and effort into bringing this future forward. We're going to be taking a short break, about 5 minutes. Let you stretch your legs, get some water, coffee, whatever you need. We'll be back with a short video. It's a sneak peek of ZeroAvia's new testbed aircraft, the Dornier 228. And after that, we'll move on to our final session of the summit, looking at wider. Hello, everyone, and welcome back to the second annual Hydrogen Aviation Summit. I am your MC, Lisa Ann Pinkerton, founder and chairwoman of Women in Clean Tech and Sustainability, and founder and CEO of Technica Communications. Thank you for continuing to be with us today. We have a sneak peek, like I mentioned before, of our Dornier 228, which arrived at the Cotswold Airport a few weeks ago. And this is the test bed for our 19-seat program. So we want to show you a quick video about that monumentous day. Roll the tape.
Today, we are anticipating the arrival of our new aircraft. So this is the 19-seat aircraft, which we have been waiting for quite a while. And it's arriving today to its home. This is the largest aircraft the ZeroAvia owned, and this will be our test bed. Yeah, the competition is there. They have 3 different prototypes introduced last year. The first of them will be introduced to the commercial operations in 2035. This is not ambitious enough for us. So we are trying to fly at the end of this year, the 19-seat aircraft already, certify the powertrain for the 19-seat aircraft in 2024, and do the same thing for the 50-plus seater in 2026. So this is 5 years from now, not 15 years from now. We need to leverage what already exists. And today, there are 10,000 plus aircraft flying in 10 to 19 seat category. So why don't we start working with them? And this is exactly what we are going to do when we certify our powertrain. This is Dornier 228. It will be our test bed for our future R&D development. We already finished the design of the powertrain. So we have done the homework, the design. We even manufactured some of the parts. So they will be, when the aircraft will be here, we will be able to start already work on the aircraft. We are not reinventing the wheel, but we reinventing the engine. And our team is ready.
Fantastic, so exciting. Real development, real flying happening with ZeroAvia. And it's going to be happening very soon. So please stay tuned for our latest milestones and developments. Now we have our final session, and we're going to cover hydrogen zero emission applications at airports. As always, please put your questions in the Q&A function down below at the bottom of your screen. And if we don't get to everyone's questions, we will do our best to answer them after the event. So I'd like to welcome to the floor our moderator for this panel and chair. She's an incredible journalist who's been at the Financial Times since 1987. A fun fact, that was the year that YouTube's Joshua Tree won the Grammy as Best Album. So she's been around for a while and she knows her stuff. She's now the international business editor and assistant editor at the Financial Times. So please welcome the exceptional Peggy Hollinger.
Thank you very much, Lisa Ann. It's very intimidating after an introduction like that, but thank you very much. So as Lisa Ann said, thank you and welcome to the audience to our session today on hydrogen in the wider aviation ecosystem. There's a lot riding on the development of hydrogen applications for aviation, as no doubt you've been hearing through the rest of these other sessions. Earlier this month, IATA, the aviation trade body, committed to reaching net zero emissions by 2050. And while some 65% of that reduction is expected to come from the development and use of sustainable aviation fuels, both hydrogen and electrically powered flight will be crucial to meeting that goal. So until now, the focus has been on propulsion, but for aviation to be truly carbon neutral, I think perhaps one day truly emissions free, we have to consider the wider aviation ecosystem. While hydrogen clearly has its limits in ferrying passengers through the air at the moment, there may be wider uses across the aviation network that can help to cut the industry's emissions, such as transport, heating, backup power, etc. But there are challenges, not least the funding. According to the IEA, the International Energy Agency, governments and private investors have only come up with 1/4 of the investment required by 2030 to make hydrogen energy align with the goal of net zero carbon. 17 countries have released plans for the use and development of hydrogen power, up from 3 in 2019, so a huge increase, but only $300 billion has actually been invested into the development of the required technology versus an IEA estimated need of 1.2 trillion by 2030. So that there's quite a big mountain to climb and a very big challenge. So to discuss those challenges and the opportunities, I have with me 3 formidable voices to put this into perspective. I'd like to introduce first our first panelist, Diana Birkett Rakow, who is the Vice President of Sustainability and Public Affairs at Alaska Airlines, the 5th largest airline in the US. Alaska Air Group is an investor in and partner of ZeroAvia, and this week the 2 companies announced that they would collaborate on the development of a hydrogen powertrain for 76-seater aircraft. We also have with us Phil Blythe, Professor of Intelligent Transport Systems at Newcastle University. Phil was formerly the Chief Scientific Advisor at the UK's Department for Transport, and I believe he's been an advocate for hydrogen in transport for many years. And finally, I have to announce a change to the program. We don't have Julian Renz, head of programs from ZeroAvia with us. I'm not going to say, unfortunately, we don't have him, because actually it's good news. His wife is having a baby as we speak, or has just had the baby. So he has been replaced by Moritz Wardenberg, another expert, associate partner at McKinsey. Moritz focuses on hydrogen use cases at McKinsey and is also the co-author of the report Hydrogen Powered Aviation for the European Commission and I believe Clean Skies. So before we start with our panelists, I just want to remind you, Lisa Ann's already told you, but please do this. We want this to be an interactive session and we want it to be useful to you, the panelists. So please do post your questions. We'll certainly come back to them towards the end, but we may even sort of feed them in throughout the session. So please remember to use that comment box. And now I'd quite like to ask each of our panelists to describe their own interest in the question of how hydrogen fits into the wider aviation universe. Diana, I'll ask you to go first.
Thanks, Peggy. I'm happy to, and good morning. I'm thrilled to be here and really excited to be partnered with ZeroAvia, and I'll just touch on a little bit sort of how this partnership fits into our net zero strategy. So as Peggy said, we are the 5th largest airline in the US. We're based in Seattle, Washington. We did grow up sort of early in our 90-year history serving rural Alaska and continue to do so today. And so kind of bring from that experience a real ethos around connection and responsibility to people and the land around us. But we are the #1 airline on the West Coast and serve North and Central America, and then the globe as a member of One World. So we come to this conversation having made a commitment earlier this year to achieve net zero by 2040. We talked a lot with our board about the imperative to have a bold climate target. Also to have short-term targets, which we've set for 2025, focused on fuel efficiency, of our operation and our aircraft, but a longer term target to really galvanize us to look at technology that are the emerging and next generation technology to help us get there. And we didn't want to jump in blind, so we developed a 5-part path to that net zero target. So the first part of the path is operational efficiency. That includes running our airline as tightly as possible, eliminating waste. That also, however, includes reducing the climate impact of our ground services equipment, which is a small percentage of our overall carbon emissions, but a place where it may be possible for hydrogen to play a role in airport power longer term. The second pillar is the evolution of our fleet. So we're bringing on the 737-9 MAX aircraft, which are about 25% more fuel efficient than the aircraft they're replacing. The third pillar is sustainable aviation fuel. The fourth, novel propulsion, which I'll come back to. And the fifth, credible carbon offsets, which really we only want to use as a last resort to close the gap to our target. Our aim is as much as possible to fundamentally decarbonize our operation. And then again, depending on sort of the pace of technological advancement and supply of things like novel propulsion and SAF, to use carbon offsets to close that gap. So in terms of novel propulsion, certainly the partnership that Peggy referred to plays a significant role there. And I know we'll talk today about a broader set of hydrogen applications, but we are really excited. We've got these 76-seat Q400 aircraft in our fleet that are powered on today traditional propeller based engines. And we're really excited to be working with ZeroAvia to replace the powertrain there with hydrogen powered hydrogen electric technology that will be zero emissions and really prove the concept of zero emissions flight in slightly larger scale regional operations and kind of move from there. So I look forward to learning from the true experts on hydrogen, who are my other panelists on the panel. So I hope Peggy directs all very difficult questions to them, but really glad to be here in this conversation today.
Thank you, Diana. I'm sure you'll get your fair share of difficult questions. So next, let's turn to Phil. I mean, in your many decades, I don't know, 2 decades or more experience in trying to think about the challenge of hydrogen and transport, and how do you feel it should be used and what are we missing?
Okay, I haven't been working on hydrogen that long. In fact, I used to have quite a negative view about hydrogen because when it was looked at from a transport-specific use only, the economics never stacked up. And I think it's only that now we're seeing other sectors going to be demanding hydrogen generation and use that it makes a lot of sense for transport. When I was CSA down at DFT for 6 years, I stepped down in June this year. For most of those 6 years, I was a lone voice of hydrogen in the DFT. They were convinced that most transport modes could be electrified, and clearly that isn't the case. And it took a long time to get the department and other government departments to think about hydrogen and the multi-uses it can have in all transport modes and the like. I think that's what makes it interesting to look at what are the opportunities around aviation and airports. And there are a lot of unanswered questions about the use of hydrogen. You know, we're about 12 years behind using hydrogen at scale compared to where we are with electromobility for road transport. And so we have to learn. And as CSA, I won the funding through last year's spending review in the UK for the Teesside Hydrogen Transport Hub, where we've got practical demonstrations and trials and use of hydrogen on the ground to actually understand all those problematic things about making it an ecosystem that everybody can use. But one of the strengths of hydrogen is, and this was being discussed in the third session before this one, is you can generate hydrogen on site using electrolysis, cracking water into hydrogen and oxygen, or getting it pumped in through a gas network. And the gas networks in the UK are really desperate to be able to do that in the future, simply because they'll be a stranded asset otherwise, so they won't be pumping natural gas and methane around the network in 20 years' time. If you can start generating your hydrogen or getting large amounts of hydrogen into an airport, you can begin to think about what you need for air services, refueling aircraft, but you can look about a whole range of other services that can use hydrogen. ground transport being the obvious one, but also the heating of buildings, the use of it for cooking and you know, all those customer facing services. I think that's definitely worth looking at and looking at now, because if hydrogen is coming along, you want to make sure that you can get the infrastructure and understand what the best infrastructure is and begin preparing that in time so it's ready for when you have some transition towards hydrogen. Hydrogen is not the panacea for everything, certainly not in aviation, but I believe it has a role to play. With my university hat on, we have a number of projects we were awarded recently with the Royal Air Force and the RAF Air Base at Leeming in North Yorkshire. They have been badged the Sustainable Living Lab for the RAF. So we're actually looking at all their ground transportation and also their accommodation blocks for service personnel and their families, and how they could potentially be, what part of that stock could actually be converted to hydrogen. And in parallel with that, another project just funded by Innovate UK, we're working with a partner, Ulemco, where they're actually doing a conversion of an air tug, you know, for towing aircraft, both at RAF Leeming and also at Tees Valley International Airport, to run directly on hydrogen, not through a fuel cell, but actually running hydrogen in the engine. So there's lots of things going on in that whole space, and the opportunity for the airport to become part of an ecosystem for generating hydrogen, maybe not even just for themselves, but for the local area as well, and look at the economic opportunities of that. The important thing, just to finish off, is we need to begin to understand how much hydrogen is needed, and can it be generated at scale, where it's needed, and importantly, at a cost that is acceptable to the transportation sector. And we can come on to more of that later.
Brilliant. Thank you. Thank you very much, Phil. You sort of covered the broad landscape there. And it's very interesting to hear about the specific examples. And Moritz, you know, you've written a book about this. You've studied this extensively. When you look at how we make hydrogen work in aviation, what do you think are the key lessons that you found that need to be heeded right now?
So I by the way, I hope that the broadband connection is working here, because my video seems to be a bit stuck, but let me know if you can't hear me. No, I think it's an interesting scale-up challenge, right, that we're going to be facing together, that will really have kind of a hockey stick shape to it, where, you know, currently we are standing at the early stages of, you know, hydrogen growth for every sector, as a matter of fact, not only for aviation. And the reason, you know, people ask me very often, why did hydrogen not take off until today? I think one of the reasons is because we simply didn't need hydrogen. If we can rely on fossil fuels, right, and we don't have a decarbonization target, if we don't want to decarbonize our hard-to-abate sectors, we don't need hydrogen. It's more inefficient than, you know, or kind of more costly than taking fossil fuels out of the ground and using that. It's only because we want to decarbonize, and not only because we want to decarbonize 50%, but we want to go to 100%, that we start to need hydrogen, right? Because some sectors are simply impossible to abate without either biofuels or hydrogen as an alternative. And we all realize that biofuels have a role to play, but they're also limited in feedstock. So therefore, right, we are starting to rely partially on hydrogen, especially for applications where, you know, it's the only way because it's feedstock for industry, or, you know, there's just no other way because, for example, an airplane, right? Good luck trying to get it across an ocean with a battery inside of it. It's not going to happen, right? So the idea is, because of the long-range transportation need to decarbonize, we need to go to hydrogen. That is now creating a demand for hydrogen in these hard-to-abate sectors, like aviation, marine fuels, industry decarbonization, steel, we have talked about a lot, right? These are probably the earliest sectors. And these are going to create sort of a you know, virtuous cycle of reinforcing each other, because it's, you know, aviation will rely also on the uptake of hydrogen in other sectors and the availability of hydrogen in other sectors, and can rely on the availability, you know, there to also offtake and create, you know, a new offtake for this hydrogen. So there will be, you know, in our view, at least, when we look at the world, we see hydrogen now being first uptaken in some of these industries like ammonia, decarbonization, green steel. You know, we have some ground transport traction. We see also the new sectors like marine fuel, etc., that will create a demand and supply of hydrogen. You know, and then, you know, when the kind of aviation demand is coming online, we will start to already have hydrogen supply available, which will then be able to supply airports in the future. And, you know, it will just become one of the other offtakes, and we will see an ecosystem of hydrogen starting to be developed across. And so I think, I'm not sure if I'm answering your question fully, but I think that is the vision, right? That where we're going, it's not only aviation as a sector by itself, but decarbonization is creating a demand for hydrogen, which will create supply of hydrogen across the system. And we will supply airports, we will supply ports, we will supply industrial areas with the same supply overall.
Brilliant. Thank you. Thank you very much, Morris. That's a key point, isn't it? It's about the wider need for hydrogen. But I suppose, you know, someone's got to start somewhere, and we can't all hang around waiting for other sectors to do the job for us. I think that's one of the things that worries me slightly about aviation, is whether it's, you know, taking up the challenge quickly enough itself. And frankly, I think the truth is that it hasn't taken it up quickly enough. So I suppose my next question would be, at the moment, one of the big questions is, you know, how do you get enough hydrogen, green hydrogen? Do you think maybe the need is so urgent, and to kickstart that demand that you're talking about, Moritz, that we should start using blue hydrogen or gray hydrogen? I'm losing track of the different colors of the hydrogen, but, you know, should we start using the less than perfect hydrogen now so that we can start building that scale and start building those use cases? Diana, I see you nodding. Are you prepared to do that, to see that in your own operations, to start using that, or are you pursuing the perfect rather than going via the imperfect? What is your feeling about that, Diana?
You know, I was actually going to come at it a slightly different way. I'd be interested in Phil and Moritz's thoughts, but I don't think that we can wait for the perfect in aviation as a whole. And so not just in the spectrum of hydrogen, but also in the spectrum of fuels or power. Sustainable aviation fuel, especially not developed through power to liquid or some kind of carbon recapture, is also imperfect. But a lot of these sources are better than sort of current traditional fuel use significantly, and they will move us in the right direction. I think as we think about policy solutions that can enable supply of green hydrogen at scale and at cost, I think we need to not box ourselves out of using interim steps. We also have to not so invest in the interim steps that it boxes us out of getting farther down the road to better sources of green hydrogen. So again, I'd be really interested in others' thoughts, but that's our perspective.
Okay, thank you, Diana. So Phil, what's your view?
I think in the short term, I think we should consider using blue hydrogen and get the carbon capture sorted out. There's a lot of investment going into that, and some really great work going on because it's going to take a while to get electrolyzers up and running with the size and the scale that we need. I mean, I think the whole problem is something I said at the beginning. You know, we're about 12 years behind in thinking on hydrogen as to where we were with electromobility, with electric cars. You know, in 2009, a kilowatt hour of storage in lithium-ion battery was about $1,500. It's now less than $200. That's because the market has been given the certainty that people are going to use electric batteries in cars with lithium, and therefore the investment's gone in, the innovation's gone, it's gone down. And I think with the right leadership in the UK and the Hydrogen Advisory Council, the hydrogen strategy, and a bit more effort, I think the investors will recognise that it's worth putting that money into innovation in hydrogen for both storage, for transmission, and more importantly for generation. And then we'll see the efficiencies of electrolyzers go up. We'll see the cost of them go down and the cost of hydrogen go down. And I think that will be the real launch of the ecosystem. But you're right, we can't wait for that. We should use what we've got now and have that leap of faith that we will have bucket loads of green hydrogen as and where we need it, when we need it, in the not too distant future.
Brilliant. So thank you. Moritz, I can see you nodding away. Rather than ask you to say, okay, go on, fire away.
I just want to make sure that we understand, because I wanted to debunk two things. Indeed, we find that blue and green combined have, on the system level, if we use that, might lower cost by 10 to 30%, right? So I agree with both other panelists. Second, to debunk, with an autothermal reformer, we can get up to 98% of CO2 capture, and we can control upstream methane emissions to make blue hydrogen as clean, almost as clean as green. So just to make sure that, that image that was created by a certain paper recently is only one view, because yes, there may be some cracking methane in the US that is really quite dirty with a lot of upstream leakage, but there is very clean blue hydrogen around as well.
Okay, but ultimately, we've got a problem that whether it's blue or green, we're not making enough. I mean, it's still infinitesimal compared to what we need. So there's clearly going to be a transition period. And if you look at it, and I know we're talking about the wider ecosystem, but there's going to be a transition period where we'll have to run on dual systems. We might have a bit of hydrogen, a bit of electric, whether it be in the ground transport, whether you're going to have a bit of hydrogen, a bit of electric, a bit of fossil fuel, which is going to bump up costs. I mean, Moritz, have you done any studies on how much that transition period is going to increase, say, operating costs of airports or indeed of airlines, and how do they minimize that?
Yeah, we have, and the truth is simply that yes, there's an additional cost, and when you compare it to whatever that means in CO2 costs, right? It almost means like you need 100 to 200 USD per ton of CO2 taxation on CO2 to bring those infrastructure investments and the changes to the airplane and the changes to the airport, etc., into the money, so that you can actually use hydrogen or a synthetic fuel compared to the kerosene today. And so I guess for me, it's more like a question like, are we ready to commit to that as a society and set up the incentive systems and regulatory systems to enable that? Or as we see now with COP, right, are we just relying on the companies and the governments are falling behind? So in my view, actually right now, what I see is a lot more companies really having traction, really investing even ahead of what governments are demanding from themselves, versus what we actually need in place to make it economically incentivized. Because I can tell you, there's no incentive scheme in the world yet, even in ETS, right, European Trading Scheme, that is at the $100 or $200 level that I'm talking about. So that's what would be required to incentivize it from a cost perspective.
Thank you. So Diana, are you as an airline willing to pay higher airport charges in order to have a system that can transition, that's going to have to use these multiple systems? And as an airline, are you willing to pay more for your fuel in order to make this transition?
Not right now, and not in the future in terms of a cost premium. I think our focus is, and certainly understanding that infrastructure investment needs to happen, but airlines are a very capital intensive, I mean, you all know better than anyone, very capital intensive business, not a lot of margin to sort of play with. And obviously increasing costs flows through to the consumer and increases fares. And I think there's a lot of different views on whether we should be prepared, the traveling public should be prepared to pay more as we go down this road. But I think that's a little bit too easy of an out. I do think that governments need to kickstart the market. I do trust that the market will begin to operate in a more efficient way if we can start to scale supply and kickstart some development. But our goal is to get these technologies to price parity with the kinds of technologies that we have to invest in now. When you also consider the cost and risk of not just traditional fuels themselves or traditional propulsion themselves, but the climate impacts that they have.
But if you're not willing to pay, and I'm going to direct this question to Phil. So Phil, Diana said, look, the airlines are not willing to pay higher airport charges, not willing to pay higher fuel costs. We've heard from the IEA that there's a huge funding gap in what's needed for hydrogen generally. And I have somewhere a quote from Tim Clark, chief executive of Emirates Airline, who said that billions and he's not ready either. Billions and billions more is going to be required in direct government aid in order to ensure this can happen in aviation. Isn't that just copping out, really? I mean, where is all this money going to come from? I can't see governments who have just come through COVID stumping up billions for the aviation ecosystem. So in your view, where should this money come from? Phil?
The whole challenge is you can't do net zero on the cheap. I mean, the scale of the transition of what we have to do as a society in all sectors is absolutely massive. And the investment's got to come, there's got to have some leadership and some money from government, but I think also industry has to play their part too. And I think, we're seeing, as Moritz said, the investment in green industry investment is massive. People are seeing the opportunities there, but the scale needed is massive, and I don't think it can be done alone by industry at the moment. I think there does need to have that leadership and that funding from government. But the numbers are eye-watering. I mean, I don't think you don't hear governments talk yet about the scale of the transition that's needed. It's eye-wateringly big, and it's going to cost an awful lot of money, and we're not quite there. We're trying to get people bought into the concept that we need to do something, and I think there's a way to go. But yeah, aviation are a major contributor to CO2 emissions and greenhouse gas emissions, and they've got to be part of the solution in addressing that too, or they may not have a market in the future for one reason or another.
Peggy, you're on mute.
Sorry, I should be used to this after nearly 2 years of Zoom conferences. Yeah, but so Moritz, I'm going to ask you this one because, on top of the scale of the investment that's needed, we also don't know what kind of hydrogen, what form of hydrogen we're going to end up deciding on, whether it be for the ground services segment, for residential, whatever. And if you're an airport, let's say you're an airport, you might have, the buildings element that needs hydrogen, the trucks that are wander around the tarmac you might need, and then the aircraft. Does it mean you need 3 different infrastructures for 3 different forms of hydrogen? Does it mean that you need higher operating costs for electric and hydrogen? I mean, how will I decide where I need to put my investment if I'm an airport or a municipality, given that everything is so much up in the air at the moment?
I think the answer very much depends on the place where you will be. And the second factor is how we will use the hydrogen in airplanes, right? So there is, let me first focus on the second. So there is some movement around liquid hydrogen and gaseous hydrogen in airplanes directly. And then there is the synth fuel route where we integrate the hydrogen into synthetic fuels and create e-kerosene. If it's the latter, then obviously I don't have a bunch of hydrogen around in my airport in the first place, right? If it's the prior, then I will have a lot of hydrogen around. Now that really matters because if I do the prior and I have a lot of hydrogen around, then I can think about what are the other uses, like, heating my buildings, etc. That might make some sort of sense. If I don't have that, then it's just an economic decision whether I go for electrification of my heating at the airport or I go the hydrogen route, right? If I do the synthetic fuels. So that really matters. The other thing that really matters is there existing gas grid to supply the airports, yes or no? In countries where there is a gas grid, you may retrofit the gas grid and put hydrogen in there and then supply the airport with hydrogen. That makes it very efficient versus, kind of electric supply. And in versus places where this is not the case. So I'm not confusing people technically too much, but these 2 factors really matter whether the economic case for doing things with hydrogen in the airport will actually live up against electrification or not, right? And then trucking by itself is an entirely different question because we may see trucking, and logistics go to hydrogen, especially the long haul. And yes, I think regardless of what we will do on the airplanes, whether we put liquid hydrogen in there or syn fuels, there will be a case for hydrogen refueling stations at airports. So bit of a nuanced answer, but I think, you know, depending on those factors, we will see either more or less hydrogen used at airports.
Thank you. And Phil, from your integrated transport perspective, I mean, do you think that one has to make those decisions now? Do we need to trial different things, or do we wait, or just go for it because ultimately we're all in that period of working it out?
I think there's still some question mark about, you know, what would benefit most from being hydrogen rather than being electrified in terms of road transport. There's a sort of tipping point where the efficiency goes one way or the other. And it's to do with the weight and size of vehicles and also their use cases. So I know DFT is struggling with how many buses should we fund that are electric and how many should be hydrogen. It really does depend on the use case. Obviously, electric is more efficient because you only have one energy conversion from into electricity and then into batteries in the vehicle. Whereas with hydrogen, you've obviously had two energy conversions to make hydrogen. So there's an efficiency loss of hydrogen there. But then if you think about it as a whole system, that bus has probably got 3 tons of lithium-ion batteries on board if it's electric. So you've got to move that 3 tons of weight and the energy to move that weight before you're doing anything useful with the bus. You don't have the same issue with hydrogen. So, you know, you've got to think of that more systems based approach as well. And if, as you see with many airports, they're also generating electricity now, green electricity through solar and through wind. One thing we have with renewables is we're not quite sure when they're going to run and generate electricity. And quite often you've got spare electricity that you can't even sell to your neighbors or neighboring countries at a negative price. So you either dump it or you store it. And one of the great arguments for hydrogen is that unwanted electricity can be stored in the energy vector of hydrogen for use either as hydrogen or turning it back to electricity at some other point of view. So to answer some of those questions, you've got to think of that wider systems approach, and it's very, very interactive. Rather than just say we're going to do this, you've got to think about what the implications of the rest of the ecosystem are. And when you begin to do that, hydrogen stacks up probably more than if you just look at it as an individual application.
Interesting. I mean, Diana, this idea of a systems, I mean, you as an airline operator are very much part of a system that works, you know, hugely efficiently with very short turnaround times. And listening to all of this questioning about how hydrogen can be applied and how people have to make these big investment decisions, I mean, how are you going to, isn't there a challenge in how you're balancing that sort of on the ground infrastructure? I mean, how do you as an airline operator regard that, and what is absolutely crucial for you, and what does this mean in terms of, you know, your involvement in how these airports are run and your investment indeed in fuel storage systems and fuel supply systems?
There's a lot there in that question, Peggy.
Sorry,
spend all day
just kept rolling around.
No. It is. It's incredibly complex. I think I'll try to take a couple cracks at it. One, the systems perspective I actually think is really critical, and it actually ties back to your question earlier about cost, or rather investment as in terms of paying the premium. Alaska Airlines alone, I mean, we just came out of 2 years of COVID. We had our first profitable quarter in 2 years, and we're far from recovery. We alone can't solve this problem, nor can any airline alone, nor can any piece of the industry alone. And I actually think the industry alone can't solve it. So there is sort of a bigger systems perspective that's needed between government, between industry, OEMs, airlines, but also, as we're seeing now with sustainable aviation fuels, corporates that use travel, like McKinsey, to do their business are willing to invest in order to hit their own goals of reducing Scope 3 emissions. And there's a lot of work to do to make sure that we are actually counting apples for apples in terms of actually reducing the carbon impact of these modes of transportation. But I think a systems perspective when it comes to investment is equally valuable as it is for infrastructure. So thinking about infrastructure then, you know, when we do an airport project, we are, involved with the airport. The airport is sort of in charge in most of them, unless it's a tenant-driven project, in which case they would delegate the design to us. But in these cases, I think they have to be airport projects. I think we can learn from some of the pilots that are happening around the world. But I think we are going to need infrastructure that is co-compatible for at the same time as hydrogen ramps up and traditional fuel and sustainable fuel are all being used at the same time. How do we enable the infrastructure to be present to go through that transition, rather than, it's not as though one day you'll just flip the switch and move from one system of fuel into the other. The last thing I would say, and it's one of the things that I think is a benefit of ZeroAvia's approach here, is just the idea of having on-site power generation as an option, rather than, and it's one of the reasons we want, not just on hydrogen, but also on sustainable fuel produced relatively close to the airports, so that we're not introducing the additional supply chain complexity, carbon impact, cost, et cetera, of transportation of a fuel product to the airport. So definitely airport redesign is going to need to be taken on. I think being able to do that at a larger government level is probably going to be best, but learning from some of the localized projects and then sharing the cost across industry and across sectors and across society, yeah. I think as Phil put it. So that's, it's mind-bogglingly complex, and I haven't written a book about it. So Moritz definitely knows more about this, but that's kind of how I think about it.
It does feel though that the cost of operating an airline and the cost of flying is going to be substantially higher than it was pre-COVID. Moritz, is that your conclusion at the end?
Yeah, there's no doubt that investments are required, right? From a report we're about to publish for COP across the hydrogen economy, we think that there will be $700 billion required until 2030 of investments. And that, you know, I forgot exactly what share is there for airports and infrastructure aviation, and that's only until 2030, and that, you know, it's many-fold that for 2050. So there's no question. Another metric, it's like, you know, we figured out that for the whole sustainable transition, we will need to allocate 7.5% of our GDP to reinvest, to make sure that, you know, we reinvent our economy entirely. Now, ultimately, that investment may be giving us the right and the highest level of long-term profitability, because, you know, we have to, right? If we are not going to do this, then, you know, we won't have a world to live in 2050. So, you know, it is the right thing to do. The question is, how are we going to transition now? You know, many people always ask me as well, like, how do you scale up all the renewables and then even more renewables that go to hydrogen? You know, it's a massive transition challenge. But the fact of the matter is, there's enough solar light and there's enough wind around in this world to make it happen, right? It's a technical challenge we have to overcome together. We have to think at the system level, how are we going to incentivize each and every player in the right way? We have to think at the government level, how we can help to incentivize and provide the right regulatory framework. We have to think as industries to come together and say, hey, can we set a fair competitive framework so that not only one airline is moving, but the airlines are moving in consortia, so that not some, like, one is disincentivized versus the other, right? These are, it's so critical to think about this together and to overcome that challenge, because yes, surely there is an investment cost, but ultimately it's a prisoner's dilemma. If we don't do it, we are all going to be facing even higher cost in 20, 30 years from now. So we have to do it.
So I'm going to ask the cheeky question. I'm a little bit of a skeptic about how optimistic and positive people are about hydrogen. Simply, not that I don't believe it's an important technology, clearly it is, but ultimately everybody's going to want hydrogen. Every single sector believes this is the answer to their problems. Phil, we know that synthetic aviation fuel, sustainable aviation fuel, and e-fuels, if we can get the technology, can also do a good job at reducing aviation's emissions and doesn't require all of this investment in ground infrastructure, in distribution, in logistics, you know, and a lot of the technology we're still working out. So we still have a lot of uncertainty ahead of us of whether we'll ever get to this hydrogen economy. Why don't we focus our efforts then on sustainable aviation fuels and the next step being e-fuels? Why do you think we have to focus on hydrogen?
Hydrogen is going to be needed for other sectors. So if there's a role within aviation, I think for some aviation, hydrogen could have a role to play. And the sustainable aviation fuels, I think we're quite a long way away from being able to generate that in the volumes that are needed. Certainly, I think Rolls-Royce have the ambition that some of the small modular nuclear reactors that they will be building will specifically be used to generate sustainable aviation fuel by pulling the carbon out of the air. Which gives you a net zero, in theory, fuel. I'm a great believer that we should spread our bets. I don't think there's one solution will solve all the problems. Same for road transport, etc. I can't see that we will just have electromobility, although there are bloody-minded people in DFT who think that is the case, and we even talk about putting catenaries, sort of electric wires above motorways, so the lorries can pick up power from that, which is absolutely bonkers. So I think you've got to look for horses for courses. I think there is a role for hydrogen for some smaller and sort of 1,000-kilometer or less range aircraft. And also bear in mind that there's going to be, because this is a whole new transition, the transition to diesel and petrol has grown over 120, 130 years. This is a whole new transition. So each of those energy vectors, each of those energy sources, there will be major demands on it. And within government, there's a thing called the Energy Innovation Board, which tries to coordinate thinking on future energy and innovation across government. And what they're trying to do is actually understand how much can individual sectors rely on electricity or biofuel or SAFs or hydrogen and the like, and then maybe there's going to have to be a priority list. But I also genuinely believe that if industry knows there's X, Y, Z amount of hydrogen needed, I think the hydrogen strategy in the UK tried to put numbers down, which I thought was very good of them. I don't know where the numbers came from, but they're quite big. Then I'm pretty certain the market will say, well, if that's the market, I'm gonna build my stuff so I can deliver that. But there is not one solution fits all. That's.
Thank you, Phil. So
Peggy?
now we've got, yeah, go on, Diana.
Peggy,
please.
do you mind if I just add? I totally
please.
agree with Phil on the spread your bets. So I suppose I'm not adding anything interesting there. But I think the other thing, and thinking about, there's a comment in the chat about, is there a study asking air travelers if they'll board a hydrogen-fueled aircraft? I don't know of that study. It'd be very interesting, but it does make me think about, sort of from an operator's perspective, anything that we do has to be understandable to our guests. And so it's another reason that I think we need to spread our bets and sort of think about the long-term change management curve of this stuff, because we do want our guests and our corporate customers to understand the impact of air travel, to understand sustainable fuel, to understand hydrogen technology, to understand, we need the regulators to understand it from a safety and security and efficiency standpoint. And that too will take time. Just as any change in sort of the service that you're used to having, or new technology, or in healthcare, new treatments, sort of take some time for the public to come to terms with. So that's not so much about the infrastructure or the cost. I think it's just a human thing that we are all going to need to go through. And I think it's another reason to think about multiple strategies and ask all of the appropriate questions.
Thank you, Diana. In fact, that's where I was going to go next, was to the audience questions, and that was it's okay. You got there. And it might be worth asking Martz, did you come across any? I mean, what is the public perception of hydrogen surrounding you everywhere, from the heating in the airport to the buses that take you to the plane itself? Is there a big challenge there?
So I was going to comment quickly, 100 years ago, somebody may have said, hey, I don't want my train to be flying because that scares me, right? So I think really it's just a behavioral adaptive challenge. And once we explain to people that, we're also burning the kerosene, we are going to also do the technical and engineering, requirements to make sure that this is safe, and have the same and very stringent safety procedures, or even more, because there are some different characteristics of hydrogen. In our studies, having talked to 20+ industry players about this, there is absolutely nothing in the way to make this entirely safe and as safe as flight with kerosene. So then there's a behavioral challenge. What I've heard is, yes, there is misconceptions out there about hydrogen. I don't actually have a survey or anything. Would be interesting. But I do think there's then, just a behavioral adaptive challenge that we need to help people and explain that we have taken the right measures, that the safety procedures are in place, that they have been adjusted for hydrogen. So for example, hydrogen acts in a different way, right? When there's a leakage with refueling, it will probably escape right up into the air. What does that mean for, our safety procedure when there is a leakage? That's probably slightly different from a kerosene that drops to the ground and may burn on the ground. So that we need to incorporate. Once we have incorporated that in our procedures that we are already talking about with our regulators on how to do that, I see no reason why people wouldn't want to fly in a hydrogen airplane.
Okay, thank you. That's very helpful. And the next question sort of feeds on from what you've just said, although from a slightly different angle. Colin Chapman is asking, is there a big problem about the indirect greenhouse gas effect of fugitive hydrogen leaks?
So if it's directed to me, so was it to Philip?
It's to whoever wants to answer that one.
I know that the global warming potential of hydrogen is much below the dose of CO2 or methane or anything, right? So I think actually the bigger challenge is there is remaining climate impact from water emissions from the plane.
Yes.
So it's almost impossible to decarbonize or go to zero climate impact, but we can go to 10-20% with hydrogen fuel cells, right? With electric, potentially we'll go to zero, but then you have this range challenge. So with synth fuels, you might still have a bit more because of NOx emissions, etc. So.
Right. He's adding that fugitive leaks affect the CH4 cycle. Forgive me, that goes beyond my knowledge. I'm not a scientist. So I don't know, Phil, do you want to take that one? Is that something you want to take?
No, that's beyond my knowledge as well, actually.
Okay, well, I'm very sorry.
Big picture thing. But what I was going to say is that there are some challenges with moving hydrogen around. I know the gas networks in the UK, particularly Northern Gas Network, are doing experiments at the moment, because when you put hydrogen through their gas pipes, the technical term is the yellow pipe, the new one, which is hydrogen, it is capable of carrying hydrogen. Because there's residue in those pipes, some hydrogen reacts with that. So the hydrogen that comes out is not as clean as the hydrogen that goes in. So there's all sorts of things that need to be understood, and whether there needs to be some additional purification of the hydrogen once it comes out of the gas network, which is may well be needed for things like fuel cells. So there's still an awful lot to understand in that. And yes, hydrogen is a very small molecule. It's a pesky little molecule, and any chance it has to escape, it will do so. But it will go up. And that then comes to another dilemma for COP26 is, do you encourage people not to fully insulate their houses so the hydrogen can get out? That's another question.
That's a whole nother question that can open a whole tin of worms there. Well, just before we've got about 5 minutes left. So I think one of the things that I would quite like to ask each of you is, again, bearing in mind that we're talking about the wider aviation ecosystem rather than just the aircraft themselves. If there's one thing that you felt we need to get moving on right now in order to define the role of hydrogen in aviation, what would it be? So Diana, what would be the thing you feel is most urgent to do right now in order to help us clarify what hydrogen's actual role will be?
That's a great question. I don't know that I have a crisp answer. I do think that there's a comment in the chat as well about needing governments to think about sort of, and maybe Moritz was talking about it, sort of how is government going to guide that behavioral, systematic financing, infrastructure transition, and sort of have a little bit of a shared plan around it. I think we do need to place bets in multiple different areas, but having a shared awareness that we are going to create some level of a hydrogen ecosystem around transportation would, it's a very simple step, but I think it's a critical one. The complexity then comes in, and we need to answer and ask all of these questions, or ask and answer all of these questions, but it is incredibly exciting to think about the potential future for especially on-site generated power from hydrogen and the multiple applications. And if we just say we're going to go do it and figure out all of the different elements that are required, I have confidence that we will.
Brilliant, thank you. Phil, what would your advice be?
I think it's think about the wider ecosystem. So you actually understand all the things that need to be brought together to make hydrogen work. And that's making sure you understand the energy system as well, and the role renewable energy will play in generating some of the hydrogen. But also making sure that all the bits and pieces like the standards and the regulations are in place at an earlier time. And also to be bold in making some educated guesses about the amount of hydrogen that's going to be needed. So the industry that's going to be challenged with generating hydrogen and storing it and distributing it know the scale that they're working to, and therefore how much investment they need. And I don't think we're talking about big enough numbers yet, because we haven't really thought about that whole system and how much of the economy could actually use hydrogen as one of their alternatives for net zero.
It strikes me with that you've got to have a lot more collaboration between sectors as well to identify that, and we're really missing that in my opinion, to actually be able to identify what we need.
Yeah, because it is absolutely multiple cross-sector, and governments tried to do that from what I saw before I left, but I still don't think they're there. I think individual departments are still thinking about what their needs are, and if you join up, there's a hell of a lot of opportunities for cost savings and the like. And also, the whole economics of hydrogen may change as you get that more joined up system, as we have done with the national electricity system and a national gas system.
Brilliant, thank you. And so Moritz, over to you to bring us to an upbeat and confident conclusion. What is your advice? Unless you want to go the other way, of course.
No. I definitely, I'm the internal.
Oh, you're on mute. Oh, no, there you go.
Can you hear me? Yeah. I'm the internal optimist, so I definitely want to end on a positive note. I think first, to answer the question, for me, building on the other panelists, right? For me, it's about offtake. So we have to create an investable framework that folks can rally around to invest in this. That can come through common industry standards. It can come through blending mandates. It can come through CO2 taxation, whatever. But there has to be the incentive for everyone to move in tandem, rather than relying on individual players, right? And I think government has a large role to play there, but we see industry stepping up a lot as well right now. And that is my encouraging message. I think what's really exciting for COP26 is that, in my opinion, for the first time, industry is in the lead and taking kind of the biggest steps ahead and showing governments what they should be doing. So that for me is really, really exciting. And finally, we are at the stage where, we are making large strides forward. So let's continue to do that together, and definitely on aviation, create an exciting change story until 2050.
Well, thank you very much, because honestly, after the last couple of weeks where I seem to read one negative story after another about whether we'll actually meet these targets, I desperately need some confidence and optimism. And I hope that COP26 delivers more than we might expect, even if I'm not terribly confident about that. I do hope they do surprise us all. I want to thank you, our panelists, Diana, Phil, and Moritz, for a fantastic and fascinating conversation. I want to thank the audience as well for the questions and for tuning in, and also ZeroAvia for inviting me to moderate and you to talk, because I found it very useful. So thank you, everybody. And I think that's the end of our session.
Thanks a lot.
Thanks very much.
Bye.
Thanks, everybody.
Thank you. Thank you so much, Peggy and panelists. Great questions, fantastic answers, very candid answers, which I really appreciate. Creating that investable framework so critical. And Peggy, I think we do have reasons to be optimistic. We will persevere.
I hope so.
We have had bigger challenges. This is probably the biggest challenge humanity has faced, addressing climate change and decarbonizing our infrastructure. And I do believe we can we can accomplish this. We have a last-minute addition to the program today before we close. It's a short message from AIG's CEO, Luis Galeao, and he sent us this video. So Ben, would you please roll the tape?
Hello everyone. IAG was the first airline group worldwide to commit to net zero emissions by 2050, and we remain resolute in our climate commitments. We are investing to speed up the development of innovative solutions and are very excited about the hydrogen electric powered aircraft. I'm very impressed with the work done by ZeroAvia's team. We believe this type of technology has the potential to help us reach our net zero emissions objective. We are both transforming our business and driving innovation to create a truly sustainable airline industry. By coming together with aircraft manufacturers, startups, suppliers, and governments, we can make a lasting difference to the world.
And thank you to Luis there for that video and for participating in our summit. We have come to a close here for the second annual Hydrogen Aviation Summit, and I'd like to hand the floor back over to the man who brought us all together, Val Miftakhov, for some closing remarks. Val, the floor is yours.
Thank you, Lucien, and thank you everybody who's still with us, and hopefully everybody loved the second day and the panels and the keynote speech and this surprise appearance by Louis. This was just in the last hour, so we really appreciate the message and the vote of confidence there. So of course, today we all heard from the people who are driving the actual applications of hydrogen in aviation. And it was great to hear from the two panels that we had, the notions of scalability in the fuel systems, systems approach to the overall cost. It was great to hear from Paul, for example, on the cost reduction trajectory and how cost is reducing already quite substantially for hydrogen production. On the it was interesting comment from Ben on grid balancing and grid connectivity of hydrogen production equipment is actually quite an interesting topic that will allow us to integrate more and more renewable energy into the grid overall as we build up the hydrogen production capacity. It's great to hear from Ahmad on the first international flight, and of course we're excited to be leading that effort from the aircraft and power plant perspective. So really exciting. On the system side, of course, Diane's great message on the don't let perfect be the enemy of the good, and we think that's definitely going to drive faster adoption of things. Local production of hydrogen and use on the airports is quite important. Maritz, great to hear for the decarbonization plan for 100% hydrogen is quite important. So really important. And Phil, it was interesting to hear the turnaround on hydrogen, not only for you, but also for the governments over the last years. And of course, all these messages together get us to a point when we're really optimistic about the future of hydrogen overall and hydrogen in aviation specifically. We, of course, at ZeroAvia believe that this is the way we're going to bring zero emission to aviation, and not just zero emission, but zero climate impact, which is quite important. It's not just about CO2, and it's not just about some other emissions. It's about the overall cycle and how we can make it zero from beginning to an end. So over the last 2 days, we've heard the technology aspects of hydrogen aviation. We heard the fuel infrastructure, deployment, scalability, and systems approach. So hopefully everybody comes out of this event with a better understanding and more optimism for future of clean aviation. And we thank you, all the participants, all the speakers and moderators, and Lisa Ann and the team at Technica and Madonna for organizing the event. And we're hoping to see you all next year. We will plan to have this event next year as well. And next year we'll have some new exciting deployments and new exciting news for you to share as well. Thank you very much.
Thank you, Val. And thank you everyone for staying with us today, joining us for 2 days. We look forward to staying in touch with you in the virtual world. So please follow our social media handles, watch our YouTube videos, subscribe to the newsletter for ZeroAvia, and you will make sure to have all of the latest updates. We have a lot of great announcements coming up soon. So please stay tuned, and we hope you have a pleasant rest of your day. Thank you. Hydrogen applications. So please enjoy your break, and we'll be back in 5 minutes.